Welcome to Algebra 1 Honors. We're looking today at Lesson 10-1, which is Order of Real Numbers. This is stuff I'm sure you have all seen before. It's very basic. Then 10-2 is going to add something new that you probably haven't worked with before. And 10-2 has a real gotcha in it that we'll emphasize to make sure you don't fall in that hole. Ordering real numbers. One way to think about real numbers is to think of them on a number line. Okay? And you have 0 as your origin. Okay? And then all of your positive numbers increase going to the right. And all of your negative numbers get smaller and smaller and smaller as you go to the left. Okay? So if you have two numbers, let's say -2 and +3. So if we have -2 here and +3 there, okay, to compare those two numbers, to figure out which one is smaller and which one is larger, one of the tricks I use to remember that is I take my two fingers and I look at the number line and I put my two fingers on the two numbers I'm comparing. Now, the number that's under my left finger, my left index finger, and you notice my left index finger, if I stick out my thumb, I get an L for less than, right? This number, the number that is under my left finger, is less than the number that's under my right finger, okay? And I'm not going to do one of these switch my hands things. So touch the two numbers. The lesser one, the smaller one, is under your left finger. Now, the way that we write that, as mathematicians, we have symbols so that we don't have to draw the number line and look at it, and we don't have to use words necessarily. We would write -2 is less than 3. Okay? Now, there's another really cute trick to help you remember. Actually, there's two of them. Help you remember which way does the sign go. Which one means less than? Okay? Because if you had a sign like this, 10, you would say is greater than 5. Right? This is the greater than symbol. But how do you remember which one is which? Well, there's two ways to do that. The less than symbol looks kind of like an L, right, that somebody sat on and it collapsed a little bit. So this is the less than. It looks like an L that somebody squished. Okay? -2 is less than 3. The other way to remember this is a cute idea, okay, that I swiped from Mr. Kiger, actually. And that is, or maybe he swiped it from somebody else. But anyway, think about this as an alligator's mouth. So an alligator's mouth is open, right? And here's its teeth. Okay, there's its teeth. Right there, and its eyes are back here somewhere. Right? There's my alligator. Okay? Now, the alligator, because the alligator's hungry, the alligator always goes to eat the greater number. So when you have two numbers, okay, and you want to compare, let's say, 7 and 11, what sign do I put in between? Well, if I think about it, 7 is going to be about here on my number line, 11's over here. My littler number is the 7. So this one is less than this one. Now, since this one is bigger, that's the one the alligator wants to eat because he wants to be well fed. So his mouth is going to go like that. He's going to go eat that number. All right, see, there's his teeth. All right, he's going to go eat that number right there. 7 is less than 11. Okay? So that's a way to remember which way the sign goes. Figure out which number is bigger, and then let the alligator's mouth eat the number that's bigger. So if we had -1 and -7, right? -1 is going to be right here. -7 is going to be out here. -7 is the littler, smaller number. Right? This is the smaller number. So the alligator is going to want to eat this one. Okay? So that says -1 is greater than -7. Okay? The alligator always eats the bigger number. Okay? All right. Now, what else is in this chapter? is notation like so. If we had 4 is less than 8 is less than 10, and you'll be asked whether or not that is a true statement. Okay? Very simple. You have to take it apart into two parts. First, you look at this and you say, okay, is 4 less than 8? Yes, if I have $4, I have less money than if I have $8. So that's true right there. Right? Then I have to look at the second part and say, okay, is 8 less than 10? Yeah, 8's less than 10. I have $8. I have less money than if I have 10. So both parts are true. So my whole statement is true. Right? Now let's look at one. What if I had 4 is less than 8 is less than 6? Okay. Well, I look at this part. 4 is less than 8. That's true. Okay. But 8, and indeed, if I compare the outside, 4 is less than 6. Okay. But 8 is not less than 6. So the second part is false. Because one part is false, that makes this whole statement false. Okay? So, just notation you may not have seen before where they nest things together like that. Just take it apart. Okay? Now, all right, the last thing that's in there is if you have something like okay? And they say, solve that inequality, find all the solutions where x is a member of, let's say, positive, real, or say positive integers. Let's even do that. Okay? So what that means is that you're looking for all of the positive integers that make this inequality true. Okay? So you only have positive integers to pick from. Picture your number line. 0, 1, 2, 3. Okay, here's our -2 right here. Okay? And here's our 5 right there. Okay, and our x is in between those two. So we're going to try -1. Well, -1 would work except that it's not a positive integer. So because our solution set is limited to this, just because of the problem, we don't put -1 in there. Okay, how about 0? Well, 0 works, but it's not a positive integer. 0 is neutral. It's not negative or positive. We put a 1 in there. A 1 works, and it is a positive integer. That's one of our solutions. Put a 2 in there for x. That works. Put a 3. That works. Put a 4. That works. Put a 5, but 5 is not less than 5. 5 is equal to 5. And we're done. All right? Now, what if it just said, instead of positive integers, it said integers, all integers? Well, now we'd have to add a little bit more to our solution set, because now 0 is an integer and it worked, and -1 is an integer and it worked. Okay, so we'd have to add -1 and 0 to our solution set. Right? What do you think we would do if it said, instead of just integers, it said all real numbers? All real numbers. Oh, listing them this way would be almost impossible, right? Because we'd have not only all of those integers, but we'd have a half and a fourth and an eighth and 1 1/2 and 1 3/4 and -1 1/2. We'd have oodles and oodles, an infinite number of solutions. So we sort of color in between here and here. Okay, and that would be our graphical solution. All of the real numbers in between there, and there are an infinite number of them, would make that inequality true. Okay? And that's pretty much what there is to lesson 10-1.